All right, we'll get started here. Welcome, everybody. My name is Kathy Mitchell-Garton. I'm with the Rocky Mountain Association of Geologists, as is Debbie Watkins, our Director of Membership. And I want to welcome you to this talk on QGIS, or QGIS, I've heard it called, by Diane Fritz. I want to thank our collaborators and the Members in Transition project. We have AAPG, SPE, the Women in Oil and Gas Association, the Colorado Oil and Gas Association, the Women's Energy Network Colorado, the CU Global Energy Program, Energy Management Program, and the Denver Well Logging Society. So great group of folks. If you are a member of any of these organizations and you've made a change recently, please remember to update your contact info with them. We all appreciate having your most recent contact information. I want to make a few announcements for upcoming events. Our next Rockies Member in Transition talk is next Thursday, October 15th, from noon to 1. And that will be with Liz Arthur and Rekha Patel. And they will be discussing transitioning to the tech industry, which they have both done. So that should be a good thing for you guys who are interested in tech, which I'm guessing you are because you're here. So we also have some other data science kinds of things coming up this fall. We have RMAG has a data science webinar series starting next week. And that's going through November 17th. Each week we'll have a different set of talks. And on November 3rd and November 17th, we'll be featuring discussions on data science, moderated discussions on data science. And those are going to be hosted by the Rockies Members in Transition folks. So Matt Bauer and Catherine Mills are going to be moderating those conversations. And then we have an intro to statistical modeling and big data analytics class coming up on October 26th. So you can register for those on RMAG's website and keep an eye out on the website and our social media feeds for upcoming more kinds of things that are going to be coming up. And finally, I want to thank Holly Lindsay for moderating this conversation today. She works for Petro DE and is a fabulous RMAG volunteer, and we love Holly. So I'm going to turn it over to her to introduce Diane. Thanks.
Wow, thanks for the kind introduction, Kathy. I appreciate it. We're very pleased to have Diane Fritz, PhD, join us today to give us a little dip into QGIS and hopefully spark our curiosity and give us a lot of tools to investigate further. Dr. Fritz is the Geospatial Services Specialist at Auraria Library, and that serves CU Denver, MSU Denver, and the Denver Community College. Dr. Fritz obtained her PhD in Geological Sciences from the University of Colorado Boulder and a BA in Biochemistry from the University of California, San Diego. Oh, that sounds nice. Her main role is on the Auraria campus is supporting the faculty and student researchers in geospatial methods and with data in their projects. Dr. Fritz discovered GIS while working on a hydrology project and now enjoys sharing her interest in geospatial technologies through the MapTime Mile High meetup group that she runs. When she's not playing with data, she enjoys being in the mountains on a bike, on foot, or on skis. Me too, Diane. I'll hand it over to you. And again, thank you for joining us today. I'm really looking forward to this.
Ooh, thanks for having me. I'm really excited to come and talk to everybody about this wonderful software. And one thing I wanted to do, just because you mentioned it in my introduction, was plug the MapTime Mile High group that I run, because this evening we are actually doing a meeting talking about wildfires and data that's associated with wildfires and making maps out of that. So if everyone doesn't have plans for tonight, that's something that you can join in as well. So today, I'm going to go ahead and share my screen here. And let's see, I need to move the faces. All right. So I'm here to talk about getting started with QGIS for everyone, and QGIS is another way people will say it. I'll go back and forth. So it is an established community-supported software that is, for making maps, and that's a lot of what we think about with GIS, but it's also very much for analyzing spatial data. So it's a very, very powerful tool, and I want to emphasize that it's good for both of those things. So why QGIS? Like I mentioned, it's really good for cartography and analysis. So if you have data, spatial data that you want to represent on a map, it's very good for being able to share that information with people quickly. If you have an environmental consulting business or whatever it is that you need to just share that information in a visual way to people that aren't tech savvy, then being able to create a map is great. But doing analysis is also a very powerful part of this. So what I'm showing here is something that I pulled off the Earth Observatory NASA.gov example of a project that they were doing. And this is satellite imagery of the Aral Sea in Russia. And we can see that over a time period that just from seeing these comparative satellite imageries, we can tell how much the surface level of the water is shrinking from what we can see in space. And we can actually do spatial analysis on that and get a very specific square kilometer feedback of what surface is no longer covered by water. What's even greater is that if we have the right kind of data layer, so if we have a bathymetry data layer that has the surface of the bottom of the lake, we can actually calculate the volume of water that is disappearing between these two images over the years. So this is just an example of the kind of calculations and analysis that you can do with the right kinds of data that you can pull into a GIS system. So in addition to those capabilities of cartography and analysis, another thing that's really great about QGIS is that it's a free and open source software. So it relies on donations, but you can download it and pull it onto your Mac or PC. So it's compatible with both kinds of computers. And you can start getting used to working with GIS data on your own time, and then contribute to the code or help developers, give feedback to them, talk to them about developing it into a tool that is a wonderful, wonderful thing. So I'm just curious, before I dive into a lot of what I'm going to talk about today, which is the basics, I want to go over some just structures about GIS so that you can get started, and then talk about expanded functionality, different kinds of plugins that these developers are creating, or more functionalities that are showing up in this software. And then at the very end, I'm going to go through a lot of resources that can help you do some self-learning with this software. But Kathy's developed a poll that I would like her to send out just so I can get a sense from everybody about if you've ever used a GIS system before at all, and just how much time I should spend talking about the data structures a bit. So this is something I'll go over really quickly regardless of what these answers are, but and these slides are going to be available to everybody to find the resources at the end, so how much time we spend kind of investigating those. All right, so I see about a third of the people have never really played directly in a GIS system before, so that's really good feedback. And in a way, if we look at a really broad definition of what a GIS system is, we all have used them, because every time we pull out a smartphone and look at Google Maps or do anything in there, that is technically using GIS, because it's geographic information and we're part of the system of interacting with that data. But if we want to talk about QGIS, then this is a desktop system that is going to give us a lot more power. All right. So I'll just go ahead and share those results really quickly if they already haven't been. So another thing that I want to do is just kind of give a quick tour of what some of the products that people have created with QGIS before look like. So I'm going to go ahead and go over to this Flickr group page that just doesn't have a lot of scientific analysis case studies in it, but it has a lot of really nice examples of the kind of things that QGIS can produce. So even what I'm showing you today from my space is going to be really rough. Know that you can make really amazing, beautiful maps like this. So for the cartography piece, you can make a really detailed map with road layers showing different kinds of towns and doing a really nice cartography product. You can create a map showing, this is one showing an example of an earthquake and some of the shock waves coming out of it and the epicenters of different shock waves coming out. And you can do analysis about where people are relative to where these seismic waves might be happening and do disaster response analysis. You can do things with network analyses where if you have a network of roads and you look at the places where people tend to drive a lot to get to work, you can get a sense of our geographic distribution of commuting in the US, for example. And you can also do really interesting things with different ways of symbolizing data within a GIS system. So this is an example that is from Mexico, and it has to do with infant mortality versus access to health services. And it's called a bivariate map, where you're looking at different colors of two different variables and how that can show up in data. And in my talk, I've mentioned that QGIS not only does 2D, but also has 3D capabilities. So here's just a really fun depiction of Mount Bachelor ski area where somebody decided to just create a nice visualization of where the lifts are on this mountain. But you can do more specific kinds of comparative things with elevation. So here is a visualization of Mount Everest compared to Mont Blanc and how their actual data and the elevation heights compare. And this was just a visualization somebody did, but you can also do math between these different kinds of raster information and get differences in elevation and do calculations. So for example, if you have a lot of borehole data and you want to compare the surface of what the potentiometric surface of water is in some place compared to the elevation of the surface of the earth, you can do these kind of calculations. People have also used LiDAR data to pull out really, really detailed patterns in the surface and digital surface models. And so here you can see old Celtic burial grounds kind of coming out in this field, just being, and people may have seen this in the news about LiDAR data, looking through the Mayan forests and seeing all of these old historical artifacts there. So there's a lot of different things that people can do with QGIS. So I just kind of wanted to give you a taster look at all of the things that people can create. So like I said, I wanted to go over some basics, and these are things that will help you get started in being able to create some of those visualizations that I just showed, and also be able to dive into some analysis projects. So I want to talk about some basic data structures, which includes vector data, raster, and one that may be not so familiar to people are mesh structures that QGIS can handle. I want to talk about projections really quickly. We're not going to dive into that real closely, but they're just really important to know about. And then we'll do a quick look at the software interface. All right, so data structures. The real world is something that we symbolize, and we create a model of it to work with it in these GIS systems. And there's two really main ones that come up. One is vector, and this is where we have basically Cartesian points, whether it is a point like a single summit of a mountain could have one latitude and longitude point. We could have lines that could symbolize, in this case, we see a road going by, or it could be for streams or any other kind of linear feature, or polygons. So in this case, we've got the outline of a building. It could be a surface of a geologic formation on the earth, or it can be just a pasture, any kind of civic boundary that we might be interested in. Behind all of these vector shapes, or each one is a feature, you can have a table of information, and this is what makes GIS really powerful, is that spreadsheet of information that sits behind what all of these shapes are can help us do things with joining different kinds of information, doing definition queries, doing analysis between what we are interested in that comes in a data set, and doing spatial analysis on it. So another kind of data structure is a raster data structure, and we're all very familiar with this when we think about taking a photograph. So when we take a photograph, each pixel in our image has a spectral color associated with it, but that pixel could also just be a binary 1 or 0 that could differentiate between land or water, for example. Or in this case, we could have a 1, 0, and a 2 showing the difference between building, a road, and then other things that we don't know. So pixels being assigned a value can have all sorts of different spectral data. Very commonly, it can have an elevation number, which helps us with digital elevation models. Those are things that we always use when we're looking at information in 3D, or just trying to model information that needs that elevation data, which is really important for a lot of our geoscience applications. So another structure is called a mesh. And this is a slightly newer kind of data structure that QGIS can support now. And it can come in triangular meshes or a regular square mesh. I just have an example of a triangle up here, and it's constructed of 3 basic things. There are the vertices, and they're numbered here, and the edges that connect those vertices. And then you can have the surfaces in between them that kind of represent that space in between. So here is an example of how multiple data sets can be held into a mesh. So if you look at the table, the 1, the 2, the 3, those represent those vertices in the diagram over on the side. And at each one of those vertices, you can have a different value loaded into this mesh data structure. And so here is an example of wind speed at different times, or you can also have different kinds of data structures hosted on that same vertices. So you can also have direction and the time associated with it. So basically, meshes are a way of holding data arrays, and that it brings a lot of power into QGIS as well. So that's a really quick look at some of the basic data structures that we have, but the configuration of how they work in a GIS system is thinking about layers. So whenever you open the software GUI, and we'll see this in a moment, you'll see having a base map and then having different layers of these different kinds of data stacked on top of it. So we might have an imagery layer. So a satellite has taken a picture of downtown Denver. We also might want to have a land cover layer, or the Surgo soils layer could be a really interesting thing, and we can do an overlay analysis of which buildings are sitting on bentonite clay, and that might be really good if you're shopping for a house, knowing whether or not your house is going to be on that kind of soil system. You can have a feature class, a vector feature class of the roads to do network analysis on that on top of it. So this is kind of how the GIS information gets stacked, and you can do comparative analysis between these layers. So that's the configuration of it. And then there are also so many different file formats. I did mention the first three that are on this list, but this is an image that I pulled right off of the QGIS user interface of all the different kinds of data structures you can load. So there's the vector that I mentioned, raster and mesh. You can also just pull in a CSV file spreadsheet that has a latitude and longitude column, and QGIS can display that as a point layer in your system. There are database connections, so Postgres and SpatialLite can be used within the system. There are web services that you can connect to be able to just pull in all sorts of different base maps. And you can import your own vector tiles or access a lot of XYZ vector tiles through web services as well. So there is a lot of options for information you can pull in. So here's a slide about the projections that I want to talk about, because this is a very, very important thing to think about when you're actually doing data analysis. Because when we look at maps, we're looking at a flat surface. And when we're looking at our laptop and we're working on the GIS system, we're also working on a flat surface. But the Earth is not flat. And so whenever we take this information and show it, there are different mathematical transformations that squish that data out into ways that distort different qualities, whether it's the direction of something, the size of something, the shape. These are all things that can be distorted depending on the different projections that we use when we flatten our data out. So a coordinate reference system, or a CRS, brings that projection choice as well as a measuring framework that gives all of your data the ability to integrate with each other. So the key is, whenever you're working with all of those different data layers that I just talked about, you need to make sure that all of the data layers you're working with have the same CRS, even though when you pull them into QGIS, it will look like they're displaying okay. It will give you a warning if they're different. But the key is to make sure that they're all the same when you actually start doing analysis or geoprocessing. The good news is you can figure out what the coordinate reference systems of your data layers are, and you can also convert them within this system. So if you've got something from one source that has a different CRS, you can convert it to whatever your project coordinate reference system is. So this is what the software GUI basically looks like. When you first get it, and I'll show you where you can download the software in the resources portion of the talk. When you first get it, it might look a little bit less complicated than this because I have some different things added into this version that I have now. But on it, you will always have a workspace where your map and your data display shows up. There's the layers area, and this is where you can just drag and drop files into this space to add them to your workspace. There are different ways of doing that. You can go to the browser window and look onto your hard drive or wherever you might store GIS data and pull things in that way as well. And then at the top, there are these main menus that talk about different kinds of layers you can add, different plugins you can add. We'll talk about that. And all of the different kinds of geoprocessing you can do. And then the toolbars are things that you can kind of custom add to your QGIS interface depending on the kinds of work that you tend to do. So you'll always want to have the Save Your Project toolbar and the navigation one to help you move around. But then there are other ones on here that are optional. So you might not really care about having a Python console in your version of it, but you can have something like that from accessing from your toolbars as well. So when you start adding data to the software, the layers will show up in that layers area, and the way that they're stacked there is how they'll appear in your working space. So here I have an OpenStreetMap standard base layer and zoomed out to the entire world. And then I have a layer of earthquake incidences that kind of happened through the 90s. I don't know why the file was called Earthquakes 1970, but that's what it was. So this is what it looks like when you have data loaded. And this is just one point layer, vector layer, on top of a raster layer that's showing a base map. Now, if I look at what this point layer of the earthquakes has in its tables or its attributes behind it, there are a lot of columns that I can do things with. So for example, I can see that there's a column here that says the magnitude of all of the different earthquakes. And I can do something with that where I can symbolize my earthquake incidences on my map based on how strong they were. So in the next slide that I have, I've gone ahead and done that with the symbology, but I'm also showing you another aspect of QGIS where there is a print composer that you can access through the main menu up in the upper left. And you just pick a new print layout, and you can work with designing your own print map directly from within this. And so here I've just symbolized these earthquakes based on their magnitude. So that's a really quick and dirty kind of overlook of what you can do with just symbolizing and showing data. So expanding the functionality of QGIS just beyond loading in data and colorizing it and looking at it and making it look pretty so that it speaks to whoever you're trying to communicate with. There are so many different kinds of functions that you can get out of QGIS. So it is a thing that is created by volunteer developers, and it is a really, really, really great community, and people are writing these scripts and developing these plugins on their own time. There's also a core group of developers that work directly on the main part of QGIS, And every time they have a new release, there will be more amazing tools available in the processing toolbox. And so we'll go over some of those, and we'll also go over some of these plugins. So this is just some built-in capabilities, some highlights. And geoprocessing is one thing that GIS systems are born to do, right? So being able to do spatial queries, like I have a floodplain area and I want to know how many houses are going to be affected by that. I can bring in that polygon layer of what my floodplain is, and I can use it to select the number of buildings from my building layer and immediately have all of that information of the demographics of people that might be affected by that. So I can do that spatial location in there. I can bring in attributes from spreadsheets that say I get census data, and I've just got a spreadsheet tied to census tracts of where people have incomes of a certain level. I can join that to a spatial layer of census tracts and visualize that and do comparative analysis in that space. I can clip layers to just my area of interest so that I'm not doing it for the entire state of Colorado. Maybe everything I'm interested in is just on the western slope. So I can draw a line that is the continental divide, and I can clip all of my interests to just Colorado to the west of the continental divide. There are so many different ways of working with spatial data in the system. If you can think of any kind of manipulation that you want to do with it, there probably is a tool to be able to do that. And it's just kind of digging into that toolbox and finding it. So there's a 3D map view. You can use this in conjunction with a digital elevation model to be able to look at 3D renderings of things and look at, say, view sheds of what a certain perspective might give you. Or just being able to see that might communicate a little bit better what that information might look like to a user. So again, back to the borehole data, if you have that information and you can go into QGIS and interpolate a surface using the toolbox where you can do interpolations, build that surface, you can do a 3D view of it to give people a better sense very quickly of what that underground surface might look like. There's a temporal controller. So this is a brand new thing in one of the latest releases of QGIS. So when you go to QGIS.org and download a version, you'll find that there's a long-term release, and that's at 3.10 right now, but 3.14 has some of these newer pieces to it. I have 3.14, so if you're brave, go for that. But the temporal controller is something that can look at your data, and if you have a column that has date time information and is declared as a date time field, you can immediately create map animations within QGIS. There is a tool called the graphical modeler. So if you're not comfortable with writing Python code that goes in and takes all of these different functions within QGIS and writes a script for doing these things, you can do it through a graphic user interface where you can go in and pull and make these visual flow charts of a repetitive process that you might want to build for something that you're doing at your job. There is also a new thing that I honestly have not touched yet, but there is command line support in the newest version of QGIS, where you can run processing algorithms directly from an OSGeo for Windows shell, for example. So if you're somebody that really likes working with command line and you're a lot faster that way, that's something that QGIS can do now too. And another thing that I thought was a really great thing to share is the vector tile support, and then also these ideas of QML or style files where you can just pull these in and apply it to a vector layer that you already have. And instead of spending a lot of time on their cartography, there are these ready-made style files out there that can help you make beautiful maps. So for example, there is a USGS geologic QML file that you can pull in and immediately represent a geologic map and all of the surface exposures based on USGS styles for those kind of maps. So I will go, I will open up QGIS and kind of show you a couple of these things just to demonstrate. I think we'll have some time for that. But I also want to talk about some plugins as well. So these are some highlights of plugins. There are over 700 plugins that people have developed. Some of them are experimental and some of them are really tried and true and tested. And so you can choose to decide what you add to your own QGIS. I highly recommend adding quick map services because QGIS doesn't have a real easy default way to load base maps, but it does have the XYZ tiles aspect, or you can use this quick map services plugin to get a nice base map, which is really good because when you're working in that blank space and you're trying to figure out where you are, you're investigating a new data set, it's good to have that base map for orientation. QGIS is another plugin that is great if you ever need to do any geocoding, which is taking street addresses and converting them to lat and lon points. That's something that it's an interesting thing to dive into, of building your own geocoder and how well those work. But QGIS will help with that. QGIS to Web is a really interesting plugin that while you're working on this desktop platform, maybe all of a sudden somebody's saying, hey, we need to have this available as a website or an interactive map for our clients. Can you create that? And this plugin helps you leverage leaflet and open layers, which are web mapping systems, to be able to make web maps while you design them in QGIS. So if you're more comfortable working in that space, that you can create web maps from it. And then these last two are definitely geoscience focused. This one for QProf or QProfile is created for making topographic and geologic profiles. So when you have that digital elevation model, so again, it's that raster data set where the pixels have elevation information, you can draw where you want, say, your cross section to be in a QGIS system, and then get that profile and directly build a cross section based on a layer of geologic formations that you also have in there. You can also add in strike and dip information and traces for faults and different things like that, and have that symbolize on that profile so it can help you construct a geologic profile. You would need, there's actually a tutorial I'll show you about more, but you would need a secondary thing like Adobe Illustrator or Inkscape to finish building out that cross section, but this gives you a really good base to start building it. And then there's another plugin called Midvatten that is basically built for hydrogeologic investigations. And I highly recommend this very detailed tutorial that a user on GitHub that goes by JKal has built for getting comfortable with that plugin and how it works. So it has all of its information on a spatialite database And this tutorial has a example database that you can download and start working with. So before I go to resources, I think it might be useful to just kind of show a little bit of some of what I was talking about. So this is the QGIS interface with those earthquakes symbolized by magnitude on here already. And in order to do that, it's really quite simple, where I've loaded, so if I had a GIS layer somewhere, I could just drag it into this layers area. And when I right click on one of the layers in my QGIS system, it gives me a whole bunch of different menus to access through here as well. So if I go down to properties, I think I went down too far. Oh, there it is. It's just being slow. I can do things with symbology. I can do things with labeling. I can see whether or not I have that temporal controller in my data that I can do renderings here. There's a whole bunch of functionalities of things that I can do from each layer. If I want to go ahead and add plugins, then let's see, let me go back to that view. Up at the top here, there is a plugins menu. And if I go there and say manage and install plugins, then I will have a whole list of all of the ones that I can explore and add. And there are many, many, and each one, when you click on them, they'll have a little description and links to information about how you decide whether or not you want to use it. And you can decide to show experimental plugins or not. And you can also see ratings and how many people have actually voted on it and how many people have downloaded things. So under the processing area up here, there is a link to that graphical modeler that I was talking about. And then there is also a toolbox that allows you to investigate every single kind of thing that you might want to look for. So if I just want to look at joining different kinds of spreadsheets, here it's going to tell me any kind of tool that has the word join in it. So I could join attributes by the nearest whatever. In a spatial sense, I can do it by field values. These are all more detailed tools that you can find from the drop-down menus up here for vector and raster analysis. So they have really highly used tools coming down from these main menus where you can look and see all of the different kinds of tools here. Or you can go and search more closely. So if I was looking for interpolation and I wanted to do an inverse distance weighted interpolation, I can pick my borehole data or maybe the depth of my earthquake focal centers and do an interpolated surface just to sort of see where they tend to be if that's something I'm interested in doing. Another thing, here I have, in addition to the OSM base map and the earthquakes, I also pulled in a digital elevation model. You can't see it because it's very small, but if I right click on this and I zoom to my layer, we'll see that I am right over the entrance of Sunshine Canyon into the city of Boulder. And what a DEM looks like when you first load it is just sort of this grayscale raster that's having high elevation from white to lower elevation to dark. And what I've done with this is if I go up to view up here and say new 3D map view, I've created one here, and I just want to make this a little bit bigger so that you can see it. But you can go in and configure your DEM to actually render as a 3D image. And if I turn off my layers and I still go look at that map, I have that OSM base map kind of draped over the top of it, so I can still see that information just sitting on top of the DEM. So I don't have to look at the DEM, I can just use it as a tool for structuring what my 3D visualization is like. And so that's what that Mount Bachelor piece was like, is showing you the satellite imagery of Mount Bachelor on top of the DEM of that space. So those are just some of the quick things that can be done there in that interface. And so now I want to talk a little bit more about all of the resources that you can find to get started and do some of this. So I will go over these very quickly so we can leave some time for questions. But QGIS.org is where you can download the software for Mac or PC. And they also have a training module, really good documentation. It's a really great site. If you are a book kind of person and you want a hard copy of something to look through, Locate Press is great for just getting this Discover QGIS by Kurt Menke is a really great resource. If you're interested in cartography more than analysis pieces, Anita Grasser and Gretchen Peterson have great hints about how to do nice cartography. And then again, the Python aspect of being able to work with your data through coding and create scripts for repetitive processes and do things more quickly by Gary Sherman is also great. This conference that happened this summer, the QGIS North America, has some great tutorials in it. I highly recommend. On day one, Michelle Tobias did a wonderful intro that's you can step through. She supplies the data and work through going through getting familiar with the interface. There is also a version in Spanish if you are not a native English speaker and you would prefer to have an intro in that language. They also did the same workshop for that. You can find both of those at that link. On Twitter, there is a wonderful supportive community that you can find with the hashtag GIS chat. It goes 24/7, but on Wednesdays, there is a concerted, hey, let's get together and see what kind of challenges people are facing. There are more tutorials at qgistutorials.com, which are really useful. And there are so many of them on YouTube too. So if you Google around, you can find a bunch there. And GitHub is always a place where people post a lot of elaborate tutorials like that one that I mentioned for the Mid-Vatten plugin for hydrogeological data. For like it brings in strat columns, anything like that that you might want to work with. And then there's a user group that you can join for QGIS US. QGIS is global. There's a lot of different user groups, but this one will talk about different kinds of conferences and things that are happening within this country. And then data. Here is a whole list of different kinds of data sources that would be useful for you to play with, because you can't do anything without having data to work with. USGS has a lot of different resources. There you can find DEMs, satellite imagery, hydrography layers, geological soil layers, geologic layers, less so on that just because it's, as many of you may know, hard to digitize all of that amazing work that the USGS has done to make geologic maps, but they are out there. There are cartography layers from Natural Earth that are really good just for accentuating nice maps. JAXA has a global coverage of 30 meter by 30 meter DEMs. You can always find all sorts of information at city and state data portals. There's one for the Colorado Oil and Gas, has a lot of information about well data that you can use, and just searching around for that. For city portals, if you're interested in a specific area, there's all sorts of interesting information there. And if you go to geoblacklight.org, that gives you a space where all of these different academic institutions like Stanford and Cornell and CU Boulder all have data portals that have open data that anybody can pull down. So that's a quick look at that. And so I think we have a little bit of time for some questions, but also happy to answer any questions via email. And this is my email address, and we can open the floor to questions, and or I can show you some of those resource websites in a little more detail.
Thank you so much, Diane. We do have a few questions, and then if we have a little extra time, maybe we can do that. Tom Feldkamp had asked, are there gridding and contouring capabilities in QGIS or plugins available for using our own data for gridding and contouring?
Yes, there are. So again, going to that toolbox and typing in grid or typing in contour, but there is, with 314, there is an instant contour renderer as a way of showing DEMs. So you can do that, but you can also create contours off of DEM layers and have a specific vector file that is a contour layer. And same things with grids, is that they can generate, you can design like, I want a grid that's sort of like this, and have it generate. So yes.
Great, great. I think I know the answer to Megan's question. Can you convert data to different projections within QGIS? I'm pretty sure I've done that, but if you'd like to expound on that, we'd appreciate it.
Absolutely. So there is reproject tools that are in there, and so there are different ways of doing it. When you bring in a data layer into reprojection, it will ask you which CRS, make sure that you know the CRS that you're in, which one you want to go to, and then which method you want to pick to do that transformation. But yes, that is all built into QGIS.
Great. Yeah, thank you. This was really interesting. Tom also had a question earlier about the data. I think it was on the mesh slide. That was very interesting in that you could have several different time stamps on different sets of data, as well as by space and different attributes. So hopefully we got that answered correctly, Tom. If not, reach out again, please.
Yeah, basically, if you just imagine each vertices on that mesh as being a place where a different data set can be hosted, and that different data set, I mean, by different timestamps. So the vertices are anchored in space, but whatever you stack on top of that vertex can be a different data set. So it's an array, sort of.
Excellent.
Yeah.
Thanks. Kathy Mitchell-Garten has asked everyone to click on this feedback survey. We not only like your feedback about this one, but I believe that survey also has questions about other things we can present here in the members in transition webinars in the future. So if you would please go ahead and put in your opinions there.
Yes, thank you. Thanks, Holly.
And will this session be available with the recording or the slides?
Yes.
Ruin. Yeah, normally I cheat and take screenshots, but I didn't really have time today, so I'd appreciate that. And I know other people would too.
It'll be available on the RMAG website next week, probably. So
great, thank you.
And I'll send out this, the link to the feedback survey, as well as a link to the place where the recording will be next week, so that people who don't have a chance to fill it out now can do so later. So.
Great. Yeah, we'll use those results to find presenters on the topics that are of greatest interest for everyone.
So with that little pause, then I think if I just show a couple of pages really quick, this is the QGIS homepage, just so you'll know visually you're in the right place. It has a lot of information, and if you go up to the top, there is a under documentation, you can get a link to a lot of their training manuals, and it has a whole bunch of lessons that you can go through. There is the QGIS tutorials site, has a whole bunch of tutorials and tips that you can go through here as well. If you go to the QGIS North America page and you go, this is that Spanish version of an introduction, and here's Michelle's English version, and her the tools for the data and workshop materials are on her GitHub page. On the second day, I actually did one for doing geologic cross sections into Inkscape, so that one is up there as well. The data sites are, you know what they are. They're kind of I like the data gateway from here, because they've got this lovely green button that helps you. If you go there, click Get Data, it helps you pick where you want to look for it and say, you know, I just want to look at Colorado and just pick one county. But then you get all of these things about whether you can get the public land survey system, census, climate precip, elevation. So they do have DEMs in here, hydrography. They have the soils layer. There's all sorts of ways of getting information to play with. So those are all of those links in that last or second to last slide that I said. So go ahead and play around with them and have fun. It's a candy store, really.
It is. It really is. Diane, you also mentioned a meetup that is meeting this evening on the fire data, I think. Yes,
so
that's
this is
what I wanted to know. Thank you.
This is a meetup group that I run, and tonight we're just going to be talking about OpenStreetMap data and this task that they kind of put out for people to map a lot of things that were important for people evacuating, or the firefighters that needed to know where to get people evacuated or what houses existed. So we're going to talk about that and different kinds of data layers. But this is the website. If you just Google Map Time Mile High, you can find it. And the Zoom link will become apparent to you when you RSVP.
Okay, excellent. Yeah, and that's outline of the Cameron Peak fire several weeks ago, actually.
Yeah, this was just a screenshot that I pulled off of NCWeb when I created this event. So yeah.
Great, thank you for that.
And then we're going to be looking, in our next meeting, we're going to be looking at Google Earth Engine. So if that's of interest, that will be our next meeting after tonight. That's on October 27th, I believe.
Great.
That's great. We're just a minute after 1. So thank you so much, Diane, for sharing all of your knowledge on this topic. So it looks like it was really helpful for a lot of people. So
good.
Yeah.
Yes, thank you so much for your time.
Happy to do.